All right, everyone, welcome back to another episode. I'm here with my man Moji Karimi, co-founder, CEO, and Chief Futurist at Cemvita. Moji, welcome to the show. How's everything in your world, man?
All good. Thanks for having me, Justin. Really appreciate it.
Good, good. I noticed actually on LinkedIn, cruising through there, you were in DC recently. You either just came back or maybe you're still there. What were you doing up there, and how was that?
Yeah, well, I used to think that, if you have good science and good technology, all good things would just happen and it would just speak for itself. And as I grow older, I'm realizing the bigger picture. So, as part of that, we're playing more of a proactive role in educating, influencing, participating with policymakers. Especially, there is a lot of fluid discussions right now around CCUS and 45Q credits.
Uh-huh.
Specifically, the issue that I was advocating for is about this CCU Parity Act, which is basically if today you capture 1 ton of CO2 and you store it on the ground, you get $85 in tax credits. But if you were to utilize it, you get $60. And
Ah.
so people are incentivized to store the CO2 as opposed to utilize it. And it indirectly is kind of imposing a tax penalty for CO2 utilization. So we're trying to fix that and make it at least parity so that it's a fair playing ground both for CO2 sequestration and CO2 utilization. Of course, both are important, but sequestration, as you know, it's TRL9, something the industry's been doing for a long time. Whereas utilization as a nascent industry needs more help and support to grow.
Oh, wow. So you were up there obviously like representing Cemvita, or were you more just independent trying to get with policymakers and get in with the right people? Or how, I mean, because that seems like an awful lot of effort and a lot of time spent to try and move the needle.
Yeah, so they do these things. It's called the Hill Day, where a different kind of companies that are in the same category, like for this, it was other CO2 utilization companies. We just kind of team up together, and there's different coalitions that will help us facilitate meetings with representatives, Congress people, senators, and then we go meet them and just kind of express the need for this change that needs to happen and
Hmm.
what is the logic behind it, and really a lot of times they just don't know as much about, well, how this certain policy impacts certain companies, or sometimes there's some unintended consequences. So if you don't go there and speak up and let them know about the impact on jobs, on like technology, on US's position in terms of either national security issues or technology adoption, then they don't know. So it's about advocating. But this one was more of a teamwork. Other times when I go there about once a quarter, it could be more specific meetings, kind of a one-on-one, more directly just representing Cemvita.
Gotcha, gotcha. No, that's awesome, man. It's nice to see folks from our sort of sandbox have a voice up in that part of the world, because it goes a long ways. And man, I commend you and the team for doing that. Kind of switching gears here a little bit. I mean, although your current day to day, with regards to what you do and in Cemvita, they're vastly different than mine per se, but we share some things in common, which I didn't know until looking through it. But I noticed you spent a good chunk of your career in the drilling space up until about 2015. In oil and gas, my career has been built around drilling wells. I started in 2004 on a drilling rig. But how did I mean? Talk about a little bit the transition, because going from that, like you worked in casing drilling, and I saw you graduated in drilling engineering, again, which is vastly different than what you do now. And so, like, talk a little bit about the pivot, and then we'll get into some of the topics that you're more involved with now.
Yeah, so the short version of it is, yes, I did petroleum engineering and more focus on drilling. My first job was at a company called Tesco. I was kind of a casing drilling research engineer. Then I went to Weatherford. I did solid expandable systems, managed pressure drilling,
Yeah.
drilling with liner. I would spend hours just looking at the shell shaker, getting samples. I was doing this specific research about understanding the particle size distribution for like loft circulation material and
Yeah.
how that helps. So a few years there, even got really deep into the casing drilling. I co-authored a chapter for IADC drilling manual on casing drilling.
No way.
And I got an advice from someone, that's like, you could go become really an expert in one area, but at the same time, I had this itch of like being more kind of holistic in like learning about other things that you don't know about. I enjoy the process of learning, you know. So I started to get involved in other aspects. That's when I kind of moved from casing drilling to managed pressure drilling, other techniques, and then from there expanded to drilling, product line management, asking questions about what's the business model for the product line for the company. And through that whole thing, I got more involved in the startups and thinking of, okay, there's the big company version of this, but there's benefits for added agility, innovation that sometimes big companies are just not perfectly set up to do.
Mm-hmm.
And that got me interested in the startups. And then through that, there was a chapter that was about software for oil and gas. But then from there, I had this opportunity to join a company that wanted to commercialize DNA sequencing in
Yeah.
oil and gas. And this was basically three people that had the idea. They've raised some money, and they needed someone in Houston. The way they presented to me, they said, we're looking for someone like a hustler on the ground who work in the service industry, who knows enough people to open some doors to go try this out, And I thought that was fascinating. I wanted to, it's like, I like DNA sequencing and this whole biotech thing because it's a good learning opportunity.
Yeah.
And just the topic itself was just fascinating. Like what does DNA sequencing has to do with oil and gas? And so I ended up joining them as their first employee in Houston, first BD manager. And through that, we commercialized DNA sequencing in oil and gas, looking at DNA of microbes in the water, oil, rock, building this kind of a 23andMe type maps for the subsurface.
Yeah.
To use that data source next to geochemistry and tracer data and logs. At the time, it was used for optimizing the wall spacing. But then through that, I learned more about biotech because the main investor was Illumina, which is a really big DNA sequencing company. I mean, Illumina is the reason that DNA sequencing is affordable. I mean,
Yeah.
they build these big high throughput machines. And then from there, that eventually led to Cemvita because my co-founder, Tara, who's also my sister, that's her background is biotech. And through Biota, the DNA sequencing startup, I learned a bit about that. So we started talking more and eventually landed on Cemvita. So the point is, it wasn't like an aha moment or anything like
Right.
that. It was kind of a continuous sequence of events that just kind of aligned.
Wow. No, it's fascinating. Actually, I interviewed, so when I was podcasting for Oil and Gas Global Network, I interviewed a gentleman from Biota, and this was like very early days. This might have been like 2019. I'm drawing a blank on the gentleman's name. He was in sales. I don't know if he was here in Houston, but he
Probably
was,
Cooper.
yeah, that's it.
Yeah,
Yeah.
Cooper Gill.
Yeah. And but man, I had not, I mean, until sort of doing some research and looking into it before interviewing him, I was blown away on like the technology and what they were doing to try and understand or characterize reservoir and stuff like that. It was fascinating. And then at that point in oil and gas, there was really this like huge emergence of like just interesting tech and people from like outside of Texas, Oklahoma, Louisiana that were like coming into the space from like California and like New York and like just and then Austin emerged as this like huge oil and gas tech. And so it's been such a cool ride. And clearly you're able to you're living and breathing in that now with Cemvita and just the unique approach to solve a lot of these problems that we have in energy. And so it leads me to my next question, Moji, is do you have any core beliefs that you've changed your mind on over around energy over the last several years, or since you've transitioned into sort of this new space?
Yeah, most definitely. Because I think it's like so you have certain beliefs, but then as you get more data, and the cards get played in terms of what is possible, what's going to take longer, you have to take that into consideration too, right? And see, okay, with this new data, what do you think is possible? So for me personally, when we started Cemvita, um, in kind of 2017, 2018, we had this idea around if there's an industry around carbon capture and storage, direct air capture, carbon utilization, why isn't it that oil and gas companies are leading that? And that was a question for me. I did actually a presentation in the TPH Innovation Conference. It's still online, 2018, about this. And since then, you saw this thing happen where, for example, at the time I was using the example of why is it that carbon engineering has developed this direct air capture and not like Exxon or Chevron? What
Right.
did happen now? Well, Oxy invested and it eventually bought that. So it became an Oxy-led initiative also to scale it up, right? So in kind of in view of innovation, there's some of that leading in as opposed to letting the cards play out and then kind of joining, which is you see some of that happening in real time. So I believed in the carbon capture and utilization as something that oil and gas should really lead. So you see that happening now. Some of the other things that it was a bit of an education for me as well was around the role that in this kind of diversification of energy sources and energy transition, how fast can we actually scale up some of the renewables, some of the limitations that we're going to run into, which are physical limitations with the amount of, for example, lithium and nickel and copper that could be supplied and mined within that time frame to allow for electrification, battery, energy storage. And actually, those led to some of what we do at Cemvita to solve certain issues. But I like to think of myself as I come from oil and gas, of course, in drilling background. Lots of respect for the industry, and I am in the industry. But also, I try to understand. Like I went to New York Climate Week 2 weeks ago just to try to understand what is the view from others who are not in the industry. I go to South by Southwest for the same reason, and just sit down. If it's a presentation, I love those that it's like an environmentalist or discussions around climate justice, and it kind of trying to absorb that, and also to be a voice for the industry, in a sense that people have a certain perception, but the reality is you have a lot of millennials who are not babies anymore and have like 10, 15 years of experience and are taking up leadership positions with different companies. And they do think differently than the previous generation, but we don't have a lot of, like our voice is not the one that is what people think about. They still think about the older kind of generation and view of oil and gas that doesn't like as much change. And that's just not true. So as I go through my own kind of journey and learning, every opportunity I try to also be an advocate for the industry and Houston and painting this different picture.
Yeah, no, that's a super healthy approach. I was talking to actually this morning, talking to a gentleman from London who manages Schlumberger's branding or SLB's branding, and it was fascinating because we were talking about just the messaging and sort of like you said, like the generation who's coming up and now into these leadership roles and how important it is for traditional energy to rebrand and communicate in a way that like positively impacts the upcoming generation. And so my question to you is, going to Climate Week and South by Southwest, which is super cool. You obviously have an innate curiosity for just consuming and understanding and learning more. But would you say the people that you've spoken to, are you starting to see an increase degree of open-mindedness towards at least trying to understand what oil and gas does and how it impacts the rest of the world, or just energy? I mean, are you starting to see conversations change a little bit with those who otherwise may have just been like, no, I don't want anything to do with it?
Absolutely. And it's so tangible compared to just a few years ago. I mean, when we're pitching for our own Series A, like 2 years ago, we talked to investors out of New York or California, and they were excited about the tech. But when the conversation got to this point of saying, well, and we're based in Houston, there was a bit of like, oh, okay, and in a way that they were not big fans. They would probably rather if we're closer to them, like New York or California. This time around for our Series B, that is welcomed and they love it because they understand, oh, so you could actually build these things and you have access to infrastructure and the big companies that know how to scale these things up. Yeah. And that's really the key is scaling, building is really this next phase that needs to happen. And people at the industry are the ones who have that knowledge and expertise and background. So that has created this dialogue with the industry in Houston and financiers, innovators from all sorts of backgrounds and geographies to have the common ground. So that is happening. The other thing that I've noticed is interesting is when you go to like South by Southwest or in Climate Week, the discussion is around climate tech. Like that's what they call the category of climate tech. Whereas here we talk about energy transition. It's interesting the difference in the terminology, because the important thing about energy transition is the moment that instead of talking just about climate change or climate tech, you start talking about energy transition, it starts to become technical. Like then you have to know, well, what is the mix now? What does it need to get to? How do we get there? How do we build these things? And capital projects, infrastructure. And that's really exciting. And we need both, right? Because the climate change conversation in climate tech speaks to the why, whereas energy transition is about the how, and for me personally, I like to sit in between, kind of absorbing the why. We have our own beliefs, but also around the world, how that's viewed. Like I'm going to COP28 for the same reason, just to see from even a higher level, like what are the conversations, and to have a voice when there's a chance, but also really deep into like how do we actually do these things and build these plants, for decarbonization, for CCUS, for energy transition in general.
Yeah, no, the conversations are certainly changing. Again, I live, in the drilling world, but just even the conversations I've had with folks all, throughout, I had a fascinating conversation with a gentleman from Scotland, and he's involved with hydrogen, which I want to talk a little bit because I noticed in some of your content we're talking about gold hydrogen, which is the first time I've heard of that. But again, it's these platforms and these conversations that hopefully are helping change the mindsets of a lot of people. I'm really curious on Cemvita. Would you mind describing sort of and perhaps it was before your time, but kind of the origin story there, and then what kind of initiatives that you guys have or business that you guys conduct that are really moving the needle to help, again, move the energy industry forward?
Sure, happy to. So with Cemvita, and going back to what you were saying earlier about the branding and messaging for the industry, I'm really hoping that we could use this platform of Cemvita as an example of what the future of the industry could look like. Mm-hmm. And what I believe in is that there's going to be, this, by the way, goes into this kind of obsession that I have with like future and foresight and futurism. Because at the end of the day, when you're in a startup business, it's about making bets, right? What people are going to need in the future, and therefore, what do you need to build today, right, to be well positioned? So, basically, I think that here in the course of next kind of 5, 10, 15 years, there's going to be a new category of companies that they would not call themselves an oil and gas company or a mining company. They will be called a natural resource company. And some of that you already see happening in a sense of, Statoil became Equinor, others like dropping the oil, adding energy instead, right? So this is kind of an extension of that. And I think it's more broad, and it should be, because at the end of the day, all that these companies are doing is extracting their feedstock from nature, whether if it's hydrocarbons or if it's minerals in a mine, right? And then doing other processes to get that to the end format that makes life possible, chemicals, fuels, and everything else. And the next question is, well, then who are going to be the winners in that category? And I think the winners are going to be those who could figure out how to produce the same product at a cost that could compete, right, with the incumbent, but with the minimal carbon and environmental footprint. Because if you could do that, naturally people are just gonna pick that option, as opposed to paying more. If your product is the same price but has this environmental benefit, right?
Yeah.
And for us at Cemvita, we're making a bet that industry of biotech is one of the engines of enabling that natural resource company of the future that could bring the cost down, but also have those environmental and carbon benefits. So that's the whole thesis. And then happy to get into what that has translated into in terms of the specific applications that we're doing now and the plan for commercializing those.
No, I think it's really important to talk about those. And so I looked, through your website, you have three main business lines: the ECO2, gold hydrogen, and I think it's called Endolith. Would you mind just briefly describing what those are?
Sure. So the first one is CO2 conversion, right? And that's our core business. That's where we started with CO2 conversion. Basically using microbes that eat the CO2 as well as other carbon waste, and then turn that into other chemicals and fuels. But really the platform that we have is these microbes, when they grow, basically their cell, the weight in their body could be 30% to 50% or even more oil or lipids in their body, basically. When we extract that, it actually looks quite similar to soybean oil. So that soybean oil is what is used today to make biodiesel, to make sustainable aviation fuel, to be used as a bionaphtha, right?
Yeah.
And when you think about it, it's like, okay, the world needs all of those things, but there is also an environmental limitations to having more soybean oil. You can't get up and say, well, I'll love to have 100 times more fields of soybean tomorrow. It doesn't scale that way. And then you still have the land use, water use, fertilizer use, all those issues. And so that has led to this issue around, why we don't have more sustainable aviation fuel today, right? So case in point, we have a big partnership with United Airlines. We just announced. Yeah, and that's for, thanks. That's for 1 billion gallons of sustainable aviation fuel that will supply to them across 20 years. And this is the core of that technology, is to get to that, basically humans being able to produce the same renewable feedstock through the soybean oil alternative that does not link to agriculturally drive soybean oil. So that's the CO2 conversion business. Then we have gold hydrogen. Gold hydrogen is near and dear to my heart because of my background in oil and gas, and also for what I did before with the DNA sequencing company. Basically, we go to depleted oil and gas reservoirs and introduce a package of microbes and nutrients. And those microbes basically eat through the undercovered oil and in a process similar to dark fermentation, produce hydrogen and CO2. The CO2 we re-inject, and then we produce the hydrogen. And we call that gold hydrogen because we had this era of, oil being the black gold.
Okay.
And now we're saying, okay, well, what if we could actually influence, like we could still use the oil as a feedstock, like a natural subsurface feedstock, but turn that into something else that is of more of a demand. And, hydrogen is one of those molecules. So it's basically turning the reservoir into a bioreactor. Therefore, we don't have to build one on surface, and leveraging that natural temperature, pressure profile that exists in the subsurface, and doing subsurface biomanufacturing, because we're already storing gases, of course, CO2, but also ethylene, in this hydrogen in the subsurface. This is just going one step further and saying, can we actually produce what we want in the subsurface in ways is like integrating upstream with downstream. And especially important because we go after basically old water floods. This is all for conventionals, right? Old water floods where the industry has already done, primary, secondary, tertiary, but there is still that 20, 40, 50 more percent that is unrecovered.
Yeah.
And using microbes as just like a small chemical plant agents that could go and use the oil as the feedstock. So that's gold hydrogen. And then the third one, just to really close the loop, is the division we have for mining and metals. And so that's microbes that could extract basically the metals from the ore. Especially we have a focus on copper. So this is for copper, they call it bioleaching, especially for low grade ore in copper. That one was a bit of a surprise to me when I learned that the mining industry was already doing that at a scale. Actually, about 15% of the world copper today is produced using microbes with bioleaching. But the companies, they're not using, the most optimized and efficient microbes, using the latest and the greatest of biotech, right? So that's what we help them with for copper. And then we have a program for lithium, for a bio extraction of lithium from lithium clay, which is different than the brine, which is where 80% of lithium is produced. In the US, we have this deposit of lithium clay that goes from Oregon to Nevada, Arizona, New Mexico. That's where you have Lithium Americas, Arizona Lithium. Tesla has acreage in the same deposit, but no one knows really how to extract lithium from clay. And what they plan to do is to use the same thing with other metals, which is to use sulfuric acid. And sulfuric acid is kind of like using a hammer. It just takes everything out. Like you get a lot of sodium, potassium, and the post-processing is a bit of an issue, as well as, 40% of the capex of building out these plants is to build a sulfuric acid plant. And so it's a huge part of the operation. And we eliminate that altogether with these microbes that do bio-extraction that are more selective just to lithium and leave the other impurities behind. So that's biomining. That division is based in Denver. The rest, CO2 and gold hydrogen, are in Houston.
Man, that's crazy. These are some badass little microbes you got running around, man.
They're some are extremophiles, as they call them. They've learned how to evolve doing these crazy things. And now we have the tools to actually understand them and then to control them.
So educate me a little bit. Like, where do these microbes come from? Like, do you build them in a lab, or are they like found naturally, or like how? And maybe that's proprietary, I don't know, but like high level, how do you, like, where do you get these things from?
So this is where it gets fun. We do this thing called bioprospecting. We have a bioprospecting team in our company. Basically, they go out in nature and find these microbes and take samples, and we'll bring them, we isolate them. We have our own library of these microbes. Let's say if we need a microbe that could survive in low pH or high pH, there is maps that you know what lakes have what pH, and then you get samples, and then going to come across some of those microbes that have learned how to evolve in that condition, right? But this is not the kind of the proprietary part, but once we get them, we have to do certain optimization, both for the nutrients, understanding the genome, and really optimizing around the function that we want them to have. And that's where our scientists, microbiologists, molecular biologists, genetic engineers apply some of the tools that we develop ourselves to get the yield and productivity and function for the microbes to the intended goal. It's a bit of a new field in that a lot of the legacy of the work that has been done is around yeast and E. coli, right? That's the ones that people know. It's used extensively, breweries, everywhere else. Right. But these microbes that we're talking about, they don't just eat sugar to make alcohol. They could eat CO2 to make lipids. They could survive in high pH, low pH. And I would say one thing that I'm really proud of in our company is we're kind of pioneering this field of in situ deployment of microbes and knowing how they're going to behave and how to control them and how to get them to have a certain function, whether if it's in the reservoir, in the subsurface, or if it's in a mine, in a heap leach. And it's quite complex because there's a lot of other microbes there. I'm sure you know already about the SRBs in oil and gas that produce H2S. That causes corrosion, right? That's why we have a lot of the legacy in oil and gas around microbiology is to kill microbes with biocide.
Yeah, we do it all the time with drilling fluids. Yeah.
That's right. Yeah. And so these are the good microbes, and to be honest, it's a bit of a surprise to me why this is not a bigger thing already. Because if you think about, I've said this before, like natural gas is called that. It's because it's a natural product. And there's a lot of cases, it's microbes that make it, called methanogens.
Yeah.
These are the same microbes that are inside the belly of a cow. That's how they make methane. These are the same microbes or their cousins that are inside an anaerobic digester that is used to make renewable natural gas, RNG. And those things are being integrated into legacy oil and gas day after day. I mean, BP bought RKO Energy. A lot of other companies are really investing heavily on renewable natural gas, other bioenergy, and it's a new field. So, biology has arrived for oil and gas, definitely, but energy transition more broadly.
Yeah. Well, I would imagine, like you said, you're surprised that it hasn't really taken off, or maybe is more, is just more present in what we do on the oil and gas side, or just in general. Like it clearly there's a lot there, but it's like you said, it's new. It's kind of abstract, right? Like unless you have some idea of microbiology, you kind of think it's kind of hard to wrap your head around, which is why I think what we're doing is super important, is like educating. And because I bet like that you mentioned some of the team that you have working for you are like super smart, highly educated in the lab, like just, at a level that surpasses most people. Like, how do you plan on scaling the message to where you can get more attention, more support? Because I would imagine there's some pretty big limiters that you find, or some challenge or headwinds that I guess kind of inhibit your ability to scale, and for this thing, for everyone just to run at you and throw money at you and be like, we know this is the right answer. Like, how do you kind of plan on overcoming that? Or are you just kind of chipping away and adding brick by brick, day after day?
Honestly, the best way to do it is just to do it and show people that this is possible. I'll take an example from gold hydrogen. We work on that for about 3 years in the lab, in training the microbes to eat the oil and produce hydrogen at the bottle test, sand pack, core flood testing, right? and it worked. So then we took it to the Permian Basin. We did 2 wells, kind of huff and puff, injected the microbes, shut in the well. After 4 days, opened it. Compared to the baseline, we saw this big increase in hydrogen production. So that was like, okay, this is microbes are doing, at least, from quality point of view, they are doing the job in the subsurface, right? But that wasn't meant to be commercial production of hydrogen, right? What we're doing now, we're about to actually deploy in the field where we have injectors and producers. That whole exercise is going to create, 20 to 30 tons of hydrogen per day, which is enough to establish an offtake, right? And once we scale that, that is because the cost estimate for us is less than $1 per kilogram, right? Compared to when talking about green hydrogen, we're talking about $3, $4, or $5 plus, right? So once you scale these projects, it really, then you just can't ignore them, right? Because it would just scale. And then I think that would drive a lot of the conversations in a bigger way in wanting to understand, well, how does this work, right? But in the meantime, I mean, things like this, I think we're involved in a lot of different associations with the industry, outside the industry, just talking about the benefits of synthetic biology and biotech, industrial biotech, outside of traditional use cases in medicine and such, into this new use cases like in energy transition, decarbonization, climate tech, if you will, is important. But like I said, at the end of the day, you just have to show that the proof is in the pudding, and go and deploy these things. And that's really what myself and the rest of the team is really excited. I mean, this United announcement that we had, right? We had a meeting this morning, just like looking at the engineering package for the plant and site selection and like what EPC we're gonna involve and things like that. And that's really where things go from idea to paper to starting to building, and that's really the exciting part and the best way to show what's possible.
Yeah, you must be fired up. And so where are you able to disclose where that plant's going to be, roughly?
Not at the moment, because there's a few moving parts. What I would say is we'll love to just have more things in Texas and in and around Houston area. Also because a lot of our partners already have infrastructure here, including Oxy, of course. Yeah. So, but yeah, we're keeping an eye in other options as well.
Very cool. Very cool. I'm looking forward to seeing some content and some tours and some video footage of when that thing gets kicked off. That's huge, man. That's really exciting. Something else I wanted to touch on. I know we're coming up close to our time, but I looked at your mission statement and it emphasizes bringing profitable solutions with a positive environmental impact. Can you elaborate on some scenarios or more around that, where the pursuit of profitability has actually enhanced or could enhance environmental objectives rather than compromise them?
100%. And when we started the conversation around why I was going to DC and utilization as opposed to sequestration, it all the same thing. I think if we focus on, instead of asking for handouts and credits and things like that, if you just focus on ways to make the economical solution also be sustainable, then naturally everyone just will do more of that, and I think that is really the way to scale sustainable solution, is to make them economical. And so for us, in the projections that we have, the amount of CO2 that we could utilize, that you see some of those on the website, all of those have that undertone of these. The first bar is that they have to be economical solutions. The part that is a bit of a moving target is that, let's say, for sustainable aviation fuel project, right? We compete with basically soybean oil, right? Because from soybean oil or our Eco2 oil to the final SAF, that's the off-the-shelf easy process. Yeah. But the price of soybean oil, there's a price today, about 70 cents, and it's kind of increasing. but that could change throughout time, right? Because everyone wants the same thing. And then within that category, there is also used cooking oils, animal fat, believe it or not, is also is a big deal in like securing more oils to make sustainable aviation fuel.
Mm-hmm.
So as long as we could compete with that price, we're in business, you know.
Right.
And there is factors that is helping in that people are getting more educated about the environmental impact that you know, agriculture drive biomass could have, and that's not trivial. What I mean by that is we started off with this, okay, if it's not oil and gas, it's good. That's where the conversation was like 5 years ago, even before that, right? A lot of the environmentalists. Now what we're realizing is like, well, the only problem with oil and gas was the emission part, right? So it was this kind of linking, just focusing on the CO2. Now, if you want to use a different source of feedstock, let's say biomass is a big one, right? People assume that that's better than oil and gas, but with biomass, now they also have to look into, well, where are you getting the biomass from?
Yeah.
How much water was used? How much land was used? Did you cut down? Is this just like wood waste, or did we also have to do some deforestation in the process? And how do you compare, you know, the detriment of deforestation compared to saving whatever many tons of CO2 emissions? You know, that's a very hard question, like in terms of figuring that out.
Yeah.
And that's what I meant. Like, I think within the next few years, we may have more of a holistic approach that doesn't just index around carbon emissions, but also includes the environmental impact.
Mm-hmm.
And what we're doing here is we're saying, okay, with oil and gas and biomass, there's the emission issue, there's the environmental issue. What would never have an issue? Waste. Any kind of waste stream. CO2 being a perfect example. There's other sorts of waste as well that we could reinvent and reuse in the process. And that's where those microbes come in. Because some of these microbes exist that could use different streams of waste.
Right. No, you bring up a great point with regards to just increasing the boundary of an analysis when looking at the energy output or the emissions, because you have to consider the energy input and all the other externalities that come along with, you know, mm-hmm. producing X energy. So again, the fact that you're thinking through all this, I think is giving you that advantage, or at least helping you along the way. Again, we blew through this episode. It's just, I can't believe we're already up for time. But in the interest of time, could you please describe to the folks where they can connect with you? I'll put the link in the show notes, obviously, and your website. But besides LinkedIn, the website, is there anywhere else that you're producing content, or any other good resources that folks can check out?
Right now, I would say, yeah, LinkedIn and the website. As we have a Twitter as well, not very active right now. Okay. But we do have some exciting things in the work. I'm trying to create a different channel for marketing and messaging as well. So keep an eye for that, and probably we'll just channel those through our LinkedIn. And maybe we'll add more to our YouTube channel. There's already a good amount of content, I would say, there from previous presentations and such. But for me personally, LinkedIn is the best way to connect.
Awesome. Well, I'll make sure and put the link in the show notes. And again, really appreciate you joining me today. And for everyone out there, please subscribe, leave a review, and always make sure we're approaching energy with a radically open mind. Be kind, and always remember that everyone deserves access to energy, and we is greater than me. Thanks, everybody.